We have a wire. It's 20 centimeters long. Do you see this wire, guys, right here?
Yeah, it's a straight.
All right. This wire is 20 centimeters long. It's going to be cut into 2 pieces, and one piece is going to be a square, and the other piece is a circle. Is everybody okay with that? Yeah? Okay. So here's the thing, you guys. When we have these wires, right? So I have this wire here, right? It's straight. I'm taking part of it, and I'm making it a circle, right? And then I cut that, and I take the other part, and I make a square. Which this is like the worst square ever. But do you guys get what's happening? I have like, stop it. It's like a square right there, right there. So the idea is I only have a certain amount, and I'm cutting it into 2 pieces. Yes? Does that make sense? Okay. Well, I am going to, it says, express the total area enclosed by the piece of wire as a function of the length x of a side of a square. So we need to label this guy, one side. We're going to label that x. Okay? Good so far? So this is x. What is the perimeter of this square?
4x.
The perimeter is 4x. Good so far? Okay. Now I just used 4x of the string to make this square. Do you see that? So I have some distance x, and I took x, 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 I have 4x, and I cut it. And I have stuff left over. Now I only have 20 centimeters. So what is the leftover for the circle? How much do I have total? I had 20, but then what did I do?
Divide that by 4.
I got rid of some of it. How much did I get rid of? 4x. So how do I show that here? Minus 4x. And that's going to equal what is left over for the circle. What do I call this distance around the circle? So this is going to be the circumference.
I feel like I'm in gym.
A little bit. What is the area of the square then? What is that color? Screen. So area of the square is x squared. Circumference of the circle we already know. What's the circumference of a circle? Right? So it's 20 minus 4x. However, we also know another equation for a circle.
Diameter. Are you asking it?
I am asking, what was it?
Isn't it diameter times pi? Diameter times
Yeah, diameter times pi, but what's another thing for diameter? 2 pi r. So this equals 2 pi r, all right? Now, this is 2 pi r. I need to think about this because in this next part we need the area of a circle. What is the area of a circle?
radius squared times pi.
Area equals pi r squared. So if I want the area of a circle, right, using this information, right, then what do I need to get rid of? We need to get rid of the r, right? Well, that's really like unfortunate because I only have an r right here, but wait a second. How many variables do I have here? Right, so if I want to get rid of this r and talk about it in terms of x, what do I need to solve for here? We need to solve for r there. Perfect. How do we solve for r? Divide both sides by 2 pi. And now I have r equals 20 minus 4x over 2 pi. And that's great because now if I want the area of the circle, right, in terms of x, I can just do pi times r squared. And what was r squared again? Or r?
10 minus 2x over.
Sure. 10 minus 2x over pi. Did everybody see where that came from?
No.
You have 20, 4, and 2. 20 divided by 2 is 10.
Now
4
I
divided by 2 is 2. But we got to square that guy. And that's important because what's 10 minus 2x times 10 minus 2x?
100 minus 4x.
4x squared.
Ready? 10 minus 2x times 10 minus 2x equals 100 minus, what's this? Right, so minus 20x plus 4x squared. So let's come back here. So 100 minus 40x plus 4x squared all over, careful, pi squared. So if I want the total area, we're not there yet. So this is just the area of the circle. What's going to happen with these pi's? One of them's going to cancel out. Everybody okay so far?
Oh my god.
I know. All right, total area. Are you guys ready?
That big equation.
Total area is the area of the square plus the area of the circle. Good? All right. What is the area of the square? X squared. What is the area of the circle? 100 minus 40x plus 4x squared all over pi. If you want to be really handy, you can make this pi x squared over pi and combine it. For me, I'm totally okay just leaving here. So total. Boop, boop, boop. Okie dokie. All right, so that's it for that part, right? No, no. All right, ready? Since x is the length of the square, you guys, the value of x must be positive. So we know that x must be, how do we write the value of x being positive? Just greater than 0. Perfect. Okay. Since the length of the wire is 20 centimeters, the piece used to make the square is obviously less than that. Does that make sense? Right? Okay. Since the circle, it has to be less than 20 because the circle was also made. So what can we say about 4x? What do we know?
There's 4 sides.
It has to be less than 20. So x must be less than 5. All right. So what does the domain of the area have to be? Yep. So it's going to be from 0 to 5. Okay. Brackets or parentheses?
Brackets.
Brackets.
Parentheses.
Argue it. What's your reason?
Because there's no little thingy at the bottom.
What's that?
There's no equal to sign.
Oh, it's
Right. Why didn't we put an equal to sign there, though? Why not?
this is less than that. Less than
What happens when it's equal? What's our area?
20. It could be 20.
If x was 0,
Yeah, it can't be 0.
right? Because what would happen to the area of the square if x were 0? There wouldn't be a square, right? And that's not, we said we took this string, right? We took the string and we made a circle and we made a square. If x was 0, then we didn't make something, right? And that's not okay for this problem. We definitely made 2 shapes. So it could be like really, really small, but ultimately we cannot let this be 0. Otherwise, some of our shapes don't exist. So that is why this is parentheses. Okay, so now what we're going to do, we're going to type this guy into the calculator.
Oh, good.
I know you guys are so lucky that we get to use calculator so much more this time. So we have x squared plus 100 minus 40x plus 4x squared and parentheses divided by pi. Hopefully you guys put that in right.
Wait, all of it?
All of this, you got to put the whole area. So I put parentheses on the top, just of the 100. See, so I have x squared by itself, and then I have 100 minus 40x plus 4x squared, that's the whole top, and parentheses divided by pi. Everybody good?
I'm going to fail this unit.
Stop. All right, so now we have zoom 6, so we're all in the same place. Zoom 6.
I don't even think it's going to be because it doesn't.
It's not.
Because of the what? Yeah, so we need to go to, we need it to be greater or smaller? Greater. All right, so let's go, what do you want to use for y max? 300? Really? How about let's start with 100? Like way lame. There we go.
Yeah.
So here's 100. Wait. Wait, don't go. So we need to find for what value of x is a the smallest. What are we trying to find here, you guys?
Minimum.
The minimum.
Don't get out of
Now what's nice is we already have a left bound, right bound because this is our domain. So we get 0 for left bound. We get 5 for right bound. And we press enter again. All right. So the value of x is 2.8. So this is x is approximately 2.8. And what is the smallest area here that we could have?
14.
14.0. Hey, I think we have some units here, guys. 2.8. What are the units?
Centimeters squared.
Centimeters for x because x is a distance. So that's centimeters. What about the area, smallest area? This is centimeters squared. Do you guys have any questions about this example?
Oh my god.